Welcome to one and all. Today we are again seeing the assignment problems or assignment model in quantitative techniques in management. So as we already discussed in our first videos regarding the assignment type of problems or in assignment model, how to use the Hungarian methods or flood techniques. The steps we already discussed in our earlier videos. Now today we are going to solve the next type of problems which is used in Hungarian methods in assignment model. So this is the problems in which they are asking to us solve the following assignment problems for the minimizations. So here in this matrix tables they are given to us the task as well as the machines. The tasks are given to us 4 and machines are given to us 4. So in this assignment model or type of problems, our rows as well as columns are equal, so there is no need to balance it. So write down this matrix table once again and apply this step 1. So our step 1 is our row subtractions, in which need to identify the smallest element in each row and subtract each smallest element in that particular row values. So see, in a task A, the minimum values is 8. In task B, the minimum value is 3. In task C, the minimum value is 9. In task D, the minimum value is 17. So apply it. So task A, 8 minus 8, 0. Again 8 minus 8, 0. Again 8 minus 8, 0. 11 minus 8, 3. Move on to task B, row B. Minimum is 3, 4 minus 3, 1, 5 minus 3, 2, 6 minus 3, 3, 3 minus 3, 0. So move on to next, task C, row C. Minimum is 9, 12 minus 9, 3, 11 minus 9, 2, 10 minus 9, 1, 9 minus 9, 0. Move on to task D. Minimum is 17, 18 minus 17, 1, 21 minus 17, 4, 18 minus 17, 1, 17 minus 17, 0. So here we completed our step number 1. So next step number 2. Step number 2 is column subtractions. So select the smallest value in each column and subtract this value from each value in that column. So see, in a first column, machine 1, column 1, the minimum is 0. Machine 2, again minimum is 0. Machines 3, in column 3, minimum is 0. And machine 4, again minimum is 0. So all values remain as it is. So see here, first column 0, 0 minus 0, 0, 1 minus 0, 1, 3 minus 0, 3, 1 minus 0, 1. So move on to next column, column 2. Again minimum is 0, so 0 minus 0, 0, 2 minus 0, 2, 2 minus 0, 2, 4 minus 0, 4. Move on to machines 3, column 3. Minimum is 0, so 0 minus 0, 0, 3 minus 0, 3, 1 minus 0, 1, 1 minus 0, 1. Next column 4, 3 minus 0, 3, 0 minus 0, 0, 0 minus 0, 0, 0 minus 0, 0. So here we completed our step number 2. Now move towards step number 3. Draw the lines which covers the maximum number of zeros. So here draw the minimum vertical and horizontal lines which covers all the zeros in a reduced matrix table by inspections or by observations. Start with the rows or columns having maximum number of zeros to draw the lines. So in a row A, task A having the maximum number of zeros, 3. So draw the horizontal lines which covers the maximum number of zeros. Then next, column 4 having the maximum number of zeros. So draw the vertical lines which covers the maximum number of zeros. So here our number of lines is not equal to our number of rows and columns. So number of lines are only 2, but number of rows and columns are 4. Therefore our solution is not optimum. So let's move on to step number 5. If our solution is not optimum, then select the smallest element among all the uncovered element of the reduced matrix. So in this uncovered elements, the smallest value is 1. which is represented by in a red color. Then next subtract it from all the uncovered elements and add it to the elements at the intersections of the lines, and keeping the other elements are unchanged. So subtract this smallest value from the uncovered values. So for B, 1 minus 1 0, then 2 minus 1 1, 3 minus 1 2, again for C 3 minus 1 2, 2 minus 1 1, 1 minus 1 0. Next for D, row D, 1 minus 1 0, 4 minus 1 3, 1 minus 1 0. And for the lines of intersections we need to add over there. So 3 plus 1, the values comes 4, and those values are covered by the lines remains as it is. So these values are remains as it is. So here we completed our step 5. Then again move on to step number 3. Draw the lines which covers the maximum number of zeros. So see, for column 1 having the maximum number of zeros, so draw the vertical lines which covers the maximum number of zeros. Then column 3 having the maximum number of zeros, so draw again the vertical lines which covers that particular number of zeros. Then column 4 having the maximum number of zeros, again draw the vertical lines which covers the maximum number of zeros. Then next, machine 2 having single zeros, again draw the vertical lines which covers the maximum number of zeros. If you want to draw the lines in a horizontal way to cover that particular single zeros, you can draw it. It's again the correct way. So here your number of lines is equal to your number of rows and columns are 4 is equal to 4. Therefore your solution is optimum. So now move on to step number 4, make a assignment. So make a assignment as follows. So task A you are going to assign to machine 2 and cancel out the other successive zeros. Then task B to machine A and cancel out the other successive zeros. It's present with respect to the row wise and column wise. Then task C to machines 3 and cancel out the other successive zeros if it is present in row wise as well as in column wise. And task D to machine 4 and cancel out the other successive zeros. So here your assignment in this way: task A to machine 2 with the values 8, task B to machine 1 with the values 4, task C to machines 3 with the values 10, and task D to machines 4 with the values 17. So summation of these total values is 39. Thank you.